Okay. Well, if anyone's going to the Allied Health Student Association, I might as well lecture till 5:30, right? All right, here we go. Artifacts. So we're talking about anatomic artifacts, external, internal artifacts, grid cutoff artifacts that also can be called moire patterns, phantom image artifacts, scatter, background artifacts. If we have the cassette turned backwards, I've done that before, that can make an artifact. And then phosphor plate handling artifacts. So here is an anatomical artifact. We look down here, I've got this little swoop of soft tissue that's come into the lung, right? And it seems to be superimposing the lung tissue, right? It is from the arm. The person is either resting on their arm or they have their arm in front of them. I think they're resting on it, and that's an anatomic artifact. Over here we have external artifacts. We have a number of them. Monitor lines, safety pins, bra hooks, gown snaps, all those are external artifacts. Here's another interesting external artifact. Stuffing from the pillow. Looks like they have some kind of weird parasitic disease or something. Here we can see the state of Iowa. Proudly displayed on this person's femur. If you're walking around in sweatpants that can show up on x-rays, that might not be good material. Like whatever they used in that ink on that sweatpant may need to be rethought. Internal artifact. Now, these are not ones that we're going to try to remove. Sir, will you please remove your pacemaker so I can get a good chest x-ray. But any kind of hardware, orthopedic hardware, or any kind of device that's been installed will show up on the image. Moire artifacts or aliasing artifacts. This occurs when a grid is used and then the CR cassette is scanned afterward. So the CR moire grid artifact occurs when a stationary grid is used, so like for portables, right? And the plate is placed so that the plate reader, so that the grid lead strips are aligned parallel with the scanning direction on the reader. Okay? So let me draw a picture of what this is talking about so that we understand it, because we're talking about two different sets of lines, right? So we have a grid, right, like this, that is blocking radiation from striking the image plate, okay? And then in addition to that grid, and then we've exposed our image plate right here. So this is our image plate that we use this grid on. But then the laser is scanning in the same direction as the grid lines. When we put the CR plate in there to get our image, and it is going to create an artifact. So we need to either change the direction the laser is scanning or change the orientation of the grid to prevent that kind of artifact. Has anyone ever seen that? You've seen it? Grid artifact. We would want to.
Really seen on portables.
Yeah. This is only going to be a stationary grid. Now, we can have grid artifacts that are kind of unrelated to this, right? If for instance, we were shooting on the Bucky, but for whatever reason the grid didn't move, we would then be able to see the grid on the Bucky because it's a higher grid number, right? If we do not have our central ray adequately angled to the grid, we could have a grid artifact there. right? So this Moire artifact is an actual digital. It has to do with the way this laser works versus not being aligned appropriately to the grid. So if we see a pattern like this, we need to first ask ourselves, okay, was I aligned appropriately to the grid? Number one, why was I even using a grid on a knee x-ray, right? Like, probably don't even need a grid. Was I aligned appropriately to the grid? If so, then is it possible that I'm getting a digital artifact from the way that the image plate is being scanned? Okay. Phantom image artifact. I can see two humeruses in this, right? Yeah, the other one's really big. Probably a double exposure. They probably just forgot. They did internal and external rotation, and they forgot to change out their image plate. All right, scatter and background fogging. This goes back to the large gentleman I was doing the chest x-ray on, right? I got some scatter radiation on my image. It wound up looking like this person's playing an air guitar, right? I have this weird pattern here of exposure. Here is the back of the cassette. So this image was acquired with the cassette backwards, right? And I can even tell you this is probably an AGFA cassette because it has that plastic pattern, that reinforcement pattern inside the plastic is hexagonal in shape. Can y'all see this on the overhead, these little hexagons here? We shouldn't be seeing that. Now, additionally, the other thing that would tip us off on this is we have some quantum model. So since the image plate was not exposed appropriately, it didn't receive the remnant beam appropriately, and so we have quantum model going on. It's very pixelated looking. So if I see this, the first thing I'm going to do is look at it real closely. Is this quantum model, or did I just have the thing backwards? Right? All right. Here are some phosphor plate handling artifacts. Hopefully this isn't our fault, but the fault of the CR reader. If we're going skateboarding down the hospital halls on the CR plates, this is the kind of artifact we would expect to see, where the actual phosphor plate has been damaged because it's been crimped. Maybe a bed, like we took it halfway out of the bucky and then we pulled it out in a way such that it crimped the IR board, you know, and it bent it and torqued it in a way, or pressure even. If we put the image receptor underneath a really large patient, they squashed it and pressed it together, and now we have damaged parts of the image receptor. The entire plate is now no good, right? This would be a digital system artifact. So this is a Panorex image of teeth, right? But we have this crazy black block here, right? This is something with the system itself. This is not anything that the tech could have controlled. The system itself needs to be recalibrated or updated. There's a ghost in the machine, basically. Okay. Anytime that we are looking at these pictures and making sure that there's no artifacts, that the image was appropriately positioned, that the S numbers, the exposure index is appropriate, before we send the images to PACS, right, the last thing that we're going to do with the picture, if it meets all of the necessary criteria and is an optimal image, we can ship it off to PACS. When we do that, we're going to want to make sure that we have the facility's name, the age and condition of the patient, their birth date, and the identifying stuff, the conditions under which the patient was imaged, upright, KUB, right? Any obvious pathology, or if the patient states right flank pain. right? If the order says something else, like the order says abdomen pain, I can put abdomen pain, patient states right flank pain, right? That's a really important CYA, because every now and then a patient's going to come in and say, well, I got that aneurysm, and what they really mean is I've got arthritis, right? Patient states aneurysm. I don't see aneurysm anywhere on your paperwork. I see rheumatoid arthritis. You know, patient states aneurysm. And then I think that's it. Okay, y'all take a little break.